Hi, welcome back to Chem with Go, and this is the final installment of the conversion factors series. We're going to take a look at a non-conventional set of conversions today, and when we talk about time, especially, what I mean by non-conventional, we're not using powers of 10 to go from one unit to another, and time is a perfect example for this. There's for every minute there's 60 seconds, for every hour there's 60 minutes, for every day there's 24 hours, and so forth. So this is, again, a non-conventional or non-base 10 or non-powered of 10 sort of conversion. Let's go ahead and write out what our conversion factors would be first, or the equalities that we're going to need in order to make our conversions. Well, we're going from days to seconds in this problem, and we know that we need to probably go from days to hours. So 1 day is equal to 12 hours. Oh, not 12, 24. 24. All right. We're probably going to need to go from hours to minutes. So 1 hour is equal to 60 minutes. We're probably going to need to go from minutes to seconds. So 1 minute is equal to 60 seconds. And using these three conversion factors, we can set this up. So I'll go ahead and do that right now. 0.5 days. And we're going to go 1, 2, 3. Okay? Now, we're going to ultimately get to our answer, which is in seconds. So I want to set up the first conversion factor right here. Into this first set of parentheses, I'm going to put days on the bottom, so 1 day. And I put day on the bottom again because I want to be able to cancel out the units eventually. So 1 day is equal to 24 hours. Okay? I'm going to use this next conversion factor in the second parentheses and really just write it into a fraction again. So I have 1 hour is equal to 60 minutes. Okay? And then the last conversion factor right here goes in this one. So 1 minute is equal to 60 seconds. And if you take a look of how I set it up, the days cancel out, the hours cancel out, the minutes cancel out because they're in the numerator and the denominator, and I'm left with seconds for my final answer, which is perfect. That means I'd set it up correctly. So now let's go ahead and perform the calculation. 0.5, which is really 12 hours, times 24, so 12 times 60 times 60, and ultimately that gives us 518,400 seconds. And this is our answer. Now, if we wrote this in correct significant units, by the way, we would have to round this out to 500,000 seconds. And the reason why, again, is because if we have one significant figure in our original measurement, then that means we should have one significant figure in our final answer. Okay? So, and that's that, and I'll see you in class.